Question 3 is a fairly common particle on a rough slope question. The diagram you're given there, fairly minimalist and a load of information telling you what's going on. And it's asking you for part A is a normal reaction, part B is coefficient, and then they take away the 15 Newton force. So first thing I'm going to do is copy down the original diagram but add a load more stuff onto it, making sure that I've got a nice big diagram, not some tiny little thing, because there's quite a lot to go on there. What have I got? I've got the weight acting downwards, and that's 2.7 G. And I'm going to resolve that into its perpendicular and parallel component. So 2.7 G, that angle there is going to be 40 degrees. So that is cos 40, and 2.7 G sine 40. What have I got? I've got a reaction. That's perpendicular to the plane. I'm going to break that 15 newtons down into a parallel and perpendicular component. That angle's 50 degrees, so that's going to be 15 sine 50, not 15 G, notice it's just 15 because that's the force. And this is 15 cos 50. Anything else on there I need to put in? The other thing it does tell you in the question is it is in equilibrium, but it's on a point of sliding down the plane, and so I've got friction is going to be acting up the plane. Right, I think that's everything we need at the moment. So going into part 1 of the question, find the magnitude of a normal reaction, also part A. So I'm going to resolve perpendicular to the plane. In that direction, that is positive. R minus 2.7 G cos 40 and minus 15 sine 50 equals 0 because it's in equilibrium. And so R equals 31.76 newtons. Just plugging that into your calculator. We can only work to 2 sig fig because we're using G as 9.8. I think that's what they tell you to use. So R equals 32 newtons to 2 sig fig. However, I'd probably hang on to that 31.76 for later calculations. Part B, it wants the coefficient of friction between P and the plane. Right, so that's going to involve resolving parallel to the plane. So I'm going to resolve downwards as positive. What have I got? I've got 2.7 G sine 40. And I've got that force acting up the plane, so minus 15 cos 50, and I've got friction acting up the plane, minus friction, the force is acting parallel to the plane. It's in equilibrium, it's on the point of slipping, but it's in equilibrium, so that equals 0. And so friction equals 15 cos 50 minus 2.7 G sine 40, and that equals minus 7.37 newtons. Okay, that's friction. The negative, whoops, gone off the picture again, sorry about that. The negative indicates that the friction is acting up the plane, so I'm resolving down as positive. Next I'm going to go in, because I'm not after friction, I'm after coefficient of friction, so seven as positive, or magnitude of that, 7.37 equals mu times 31.76. And so dividing through by that, mu equals 0.23 2 sig fig. And the last part, it's now telling us that the force of 15 newtons is removed, so determine whether P moves, justifying your answer. So this bit here goes completely, so we can sort of forget about that lot. Well, what we're doing, it was on the point of slipping down the plane. I'm removing that force that's up the plane. I'm removing that, so that's going to reduce the reaction, which in turn is going to reduce friction. So and the answer is yes. Obviously. Unfortunately, that won't get you any marks. So what are we going to look at? Just going to run through everything again. So resolving in that direction, but now we're out to 15 newtons. So R minus 2.7 G cos 40 equals 0. So R is now 20.3. In which case friction equals mu. Mu has not changed. 20.3 times 0.23. 4.66 newtons. Okay, so now if I resolve that way, parallel to the plane as positive, what have I got? I've got 2G, sorry, 2.7G sine 40 minus 4.66 equals 2.7A. So 2.7A equals, I haven't worked this out, so in degrees, 2.7 times 9.8 times sine 40 minus 12.35. And so A equals 12.35 divided by 2.7 equals 4.6. And so what I've actually shown now is positive, so it is going to start to slide down the slope with an acceleration of 4.6 meters per second.